Now, Mendeleev gave his periodic table with 63 elements, and even though his work was a breakthrough and much appreciated, it had drawbacks, and thus it was not finally accepted. But where exactly was the problem? A young scientist named Henry Moseley found the problem in the periodic table and the periodic law, and he, after a lot of research, gave his periodic table, which we call modern periodic table. Now, what he found was that for elements, because periodic table is nothing but group of elements arranged in a particular order. Now, for elements, the more fundamental quantity that determines its properties is atomic number and not atomic mass. And Mendeleev and all the scientists before him thought of atomic mass being the fundamental property. But it was actually atomic number, which I hope you all know is the number of protons in an atom. Now, atomic number is the more fundamental quantity which will determine the properties. And so, this was the problem in the periodic law, the Mendeleev's periodic law. And so Henry Moseley gave his modern periodic law, which is very important. It will be asked in your exams definitely. So please take a note. So the modern periodic law states that the chemical and physical properties of elements are periodic function of atomic number of the respective element. Now, I'm sure you know the meaning already because this is very similar to the periodic law that Mendeleev gave. The only difference is this quantity, that is, it is atomic number in place of atomic mass. So this means that when we arrange elements in increasing order of their atomic number, the properties, that is both chemical and physical properties, will repeat after a certain interval of time. Now next, before looking at the modern periodic law, there are certain terms that you need to know. So first of all, what you already know is what is atomic number. Now when we speak of atomic number, one term that is very important is electronic distribution. Now what we know is that an element is neutral. It does not have any charge. So because this is neutral and atomic number is the number of protons, an element will have equal number of electrons as well. And now, so as I said, number of protons is the atomic number of an element and number of protons is equal to number of electrons. And this distribution of electrons in the shells is what determines the properties. Now this we'll be seeing later when we talk about the properties. But to tell you here, that element is made up of atoms and an atom is actually nucleus in the center which will have protons and equal number of electrons will be around it because it is neutral. Now these electrons are present in shells. The innermost is named as K, then L, M, similarly outer one will be N. Now these are the shells. And the number of protons which are present in the center will be equal to number of electrons. And these electrons are present in the shells. Now the number of electrons which are present in the last shell of any element is known as valency. So this valency is again one important term. So let us discuss a little bit about this valency first. So as I said, properties of elements come from electronic distribution. And this electronic distribution around the protons gives rise to something called as valency. Now let us talk about valency because this is very important before we speak about the modern periodic table or before we go to modern periodic table. So valency is the common definition that you'll find is it is the combining capacity of an element. Now this definition, if you don't understand, we'll take some examples. Valency is actually the number of electrons, I'll write first, So another definition for valency is that valency is the number of electrons that an atom has to lose, gain or share in order to complete its octet or to get stability. Now we'll see what stability is actually for elements. Now as I said, in the center there is proton and around it we have shells in which electrons are distributed. Now one thing that you need to know is electron distribution. Electron distributions where? In the shells. Now the innermost shell that we call as K shell can have maximum of 2 electrons. L on the other hand can have 8 electrons. Similarly, M can also have 8 electrons. Now, this much is enough for you, and now we'll take some examples. For example, now if I ask you to write electron distribution of sodium, you'll have to know its atomic number first, because atomic number is what is more fundamental, because atomic number is what is the number of protons, which will be equal to number of electrons, whose distributions we have to write here. So Na, so atomic number of Na is 11. Now please don't worry, at least from 1 to 20 you'll have to remember the atomic numbers of elements, and it will be very easy if you keep practicing daily. So Na I know is 11. So now I have to write the electronic distribution. This is KLM. Now as we know, maximum electrons that can fit in K shell is 2. So I'll write 2 here. 8 can maximum come in L shell. Now it becomes 10. Now what is required is just 1. So in the M shell, we'll have only 1 electron. If I ask you to write the electron distribution for magnesium, of course, you'll have to know its atomic number, which is 12. Now you can easily write 282. Now this is how you have to practice. I'll ask you to write for aluminium. You'll have to know its atomic number, that is 13. And then you can easily write the electronic distribution. Now once you know the electronic distribution, it is important to determine its valency. Now you see the definition. It is the number of electrons that an atom has to lose, gain or share in order to complete its octet. Octet means stable electronic configuration. Now stable electronic configuration means that in the last shell, in fact in all the shells, the number of electrons should be maximum. That means K should have 2, L should have 8, M should have 8. So now we'll see what exactly valency means, and it is very interesting. So now I hope you all remember the definition of valency. Now we'll see practically what valency is. Alright, so here we have the definition as well. Now see here. We'll start with few metals. So sodium, the electronic configuration is 281. Now to become stable or to attain octet, octet means 8 electron in its last shell. Now here, how can this configuration become stable? Now if sodium is able to lose 1 electron, the configuration becomes 2,8. Now the maximum number of electrons in any shell is fulfilled here. That means K can have maximum 2 and it is 2. L can have maximum 8 and it is actually 8. So by losing 1 electron, it is becoming stable. So the valency of sodium will be 1. Here we'll write the valency. Similarly, for magnesium, you can see that by losing these 2 electrons, it can attain stable configuration, that is 2,8. So its valency is 2. Also, for aluminium, it can become stable, that is 2,8, by losing 3 electrons. So its valency will be 3. We'll take one non-metal also. For example, I take chlorine. The atomic number is 17. Now, please remember and memorize all the elements from atomic number 1 to 20, because these are the ones which are most relevant for your exams. So chlorine is 17 and its electronic distribution is 2, 8 and 7. Now here see, there's a big change. Now you'll understand why properties depend on the electronic distribution. Now here in case of chlorine, it is a non-metal, while these are all metals. Now if you see the electronic configuration of chlorine, it is 287. Now tell me, is it easier for chlorine to remove these 7 electrons, or is it easy for it to gain 1 electron and become 288? Of course, the second option. And so for non-metals, they have the tendency to gain electrons to become stable, and metals have the tendency to lose electrons to become stable. And so after gaining 1 electron, it becomes stable. And so again, the valency of chlorine is -1 because it has gained a negative charge. Now, if this part is clear, you'll clearly understand the trends in the modern periodic table.
If you like the video, please hit the like button, comment and share it with your friends. Also, don't forget to subscribe for all our future videos.